Hello and welcome back. Today in this exciting tutorial, we're going to find out how symmetric and asymmetric keys work. Well, first of all, we're going to start with symmetric keys, and everything is quite straightforward here. You have a key, you have some data that you want to encrypt, you use that key, and then the data is encrypted, it's stored in an encrypted format, you can send it to someone else, and then to decrypt it, you need to use that same key or an identical copy of that key. So very straightforward process. The key is used for encryption and decryption. Same key is used for both. Now with asymmetric keys, it's much more interesting, and I've got a great way to help you remember about the examples we're going to look at just now. And that is by thinking of a cookie competition. How cool is that? So with a cookie competition, we're going to discover about asymmetric keys. So there's two main use cases for asymmetric keys. The first one is, of course, encryption. And let's say we are participating in a cookie competition, or there is a cookie competition. So Cookie Grandma here on the right is the judge for this competition. She's collecting recipes from everybody about their best cookie recipes, and then she makes a decision on who are the winners. She has a private key, and she distributes to the public a public key, which you can just download and you can have. Now, these keys are mathematically related. And when you take something, for example, a recipe, and you encrypt it using the public key, then nobody else, even yourself, nobody can decrypt it using the public key. It just doesn't work for decryption. In this particular case, so if you encrypt something with a public key, it won't be able to decrypt that same data. On the other hand, the private key can decrypt it. So in our cookie competition, basically any member of the public can take their treasured recipe for cookies, encrypt it using the public key, and send it to grandma, and basically not be worried that along the way somebody might grab that encrypted data and use the public key to decrypt it, because the public key won't be able to decrypt it at all. And so their recipe is safe, and they know for sure that only the cookie grandma can decrypt their recipe. So that's encryption. The second use case, and this is a very important use case that is often omitted in tutorials, is called digital signatures. So here we're going to go the other way. Now, grandma still has a private key, and the public still has the same public key as before. But now grandma has collected all the recipes from the public, has decided who are the winners, and she has a list of winners. Now she wants to distribute this list. She could just send it to the public, but then they won't know for sure that it comes from her. So what she will do is she will take this list and she will use her private key to encrypt it. Now, she cannot decrypt it using the same private key, but that doesn't really matter, because if she wanted to decrypt it for whatever reason, she can just use the public key, which is available to everybody in the world anyway. So that part is not that important, the fact that she can't decrypt it with her own key. But what is important is that now whenever a member of the public wants to read this list, they will use the public key to decrypt it and read the list. So what's the point of this? If anybody can decrypt it anyway, what's the point of hiding it in the first place? Well, the point here is that if the grandma just sent out this list to everybody, well, somebody could also make a copy of that list, and like a forged copy of that list, and also send it out. And how would we be able to verify that that list indeed comes from grandma? So what grandma is doing here, the cookie grandma is doing here, is she's encrypting this list, putting it here, and now whoever wants to read the list has to decrypt it first, and that way they will know that because this public key works for this lock, because this public key can actually open this list, then it could have not come from anybody else but grandma, because grandma is the only one with the private key. Only grandma, only the owner of the private key, which only grandma has access to, could have locked this list in such a way that this public key works. Basically, these two keys are mathematically related. If you encrypt it with the public key, only the private key can ever decrypt it. If you encrypt it with the private key, then the public key can decrypt it, and that's a confirmation that it was indeed encrypted with the private key. So that's why this use case is called a digital signature. And that's a very important use case. It is used in, for example, SSL, TLS handshakes and other applications. And look out for that, because a lot of materials online actually don't A lot of materials online say that you can only encrypt with the public key. That's not correct. You can encrypt with a public key in the case when your goal is encryption, but if your goal is digital signature, then you should encrypt with the private key, and then members of the public can verify that the encryption came from you. So there you go. That's symmetric and asymmetric keys, and I'm sure this cookie competition analogy or example will help you remember exactly how asymmetric keys work. Here's a summary of what we discussed, and I look forward to seeing you back here next time. Until then, enjoy the cloud.